In this lesson, I'd like to introduce some of the more common constellations that we see in the Northern Hemisphere and show you how to use a star chart. First of all, you need to know this term, celestial sphere. That's basically a fancy way of saying what the sky looks like to those of us who are looking at it from Earth. So it's kind of like a bowl shape that you see. Now, that's what this person sees because that's where they're standing on Earth. But if that person was standing right on the North Pole, you can imagine that the whole bowl would shift so that now they're able to see from this horizon all the way to this horizon. In fact, somebody who is standing on the North Pole, looking at these stars here, will see a completely different set of stars than someone standing on the South Pole, because the South Pole people, the ones in the Southern Hemisphere, can only see the southern set of stars. And that's because the Earth's axis is always pointed in the exact same direction. We'll talk about that again in a second. The stars, just like the sun, will appear, they won't actually, but they will seem to because of our motion. They will appear to move from the east to the west across the sky, and that's because we are rotating. If you look at us from the side angle, and here's the equator, and here's the tilt of the Earth, you can see here we are rotating counterclockwise. And then if we look straight down on the North Pole, we could see that we are again rotating counterclockwise. And that motion, that spinning that happens, really gives us our view of the sun and the stars rising on the east and the west. So here you are standing here, and you're looking up at star A. And I've drawn it here again. So there's you looking at star A, or from this angle, you looking at star A. What ends up happening is, from your perspective, you don't really feel the motion of the Earth. Instead, it feels like the celestial sphere itself is moving around you. And what you will perceive is that the star is going to rise in the east. Here's the east side. It's going to rise in the east, and it's going to come and set in your west. Rise in your east and set in your west. That's how it's going to appear to move. But what's really happening is the star is stationary, it's staying put, and you are the one turning. So here, the star is staying put, and you turn past it, but it's going to feel like it's moving past you. A really good way to illustrate this is to show you star trails. So here we are looking at some time-lapse photography, and you can see that the stars are spinning around this central location. If you look carefully, you'll see that it's actually this star that's spinning. If you know any of your constellations, you can see here's the Big Dipper rising on the right-hand side here. You can see that the stars appear to rise on the eastern side, and they appear to come down and be setting in the west. Here's another constellation that might be familiar. It's fainter to see, but it's actually the one that this is attached to, and there's the Little Dipper right there. And another famous one, there's the W shape right here. That's the Queen Cassiopeia on her throne, and her husband is nearby in a constellation. You can see that the stars begin to spin around the edges. This particular photographer has also managed to capture the auroras. And here's the final picture if you were to stack all of those photographs on top of each other. In this composite shot, it's very easy to see that there is one central star that all the stars appear to be moving around. And that star is called Polaris, or the North Star. If we look at the time-lapse photography over a shorter period of time, so let's say 20 minutes, you can see the stars are only moving a short bit. After 60 minutes, they've moved a fair bit farther, and after 3 hours, they've moved even farther. So here again, we're looking at the perspective of why the star seems to rise in the east and set in the west. It's because over time, it appears to shift. Now again, it is not shifting, we are shifting. And you can see that in the Northern Hemisphere, we are moving around a central point, and that central point is guided by the star Polaris. And again, the reason that Polaris is that central star has to do with the way our axis is pointed at the celestial North Pole. It appears to have a nice fixed location and gives us guidance to the north in the sky. Now, what do we mean by celestial North Pole? Well, let's take a look at the last diagram again. Here we've got, again, our North Pole. If we were to extend it forever out into the universe, you can see that it would cross this point right here of the celestial sphere. And so this would now be the new celestial north. And you can see the North Star is sitting right there at that junction. So that's why we would say that the North Star is at the celestial North Pole. Before we go on, it's going to be very useful if you understand the difference between a constellation, which is a grouping of stars that we have created just by connecting our own dots and deciding what the shapes are. Sort of like when you look at the clouds in the sky and you decide that you see a lumpy cloud and you think, hey, that looks a lot like a bunny rabbit or something. We've done the same thing with the stars. What's different about what we've done with the stars is that we've also built big stories around them, and some people even built religious beliefs on them, really believing that the gods were up in the stars and that the stars were the story of those gods. In particular here, the ones that we're going to look at, we're actually looking at a constellation, which is a giant grouping of stars. This one is actually called Ursa Major. Ursa means bear, and Major is the big bear. So this is the big bear here. And when we talk about the Big Dipper, we're talking about only a small portion of the Ursa Major constellation. So the Big Dipper is made up of these 7 stars. We call it the Big Dipper because it looks a lot like a ladle. There's the handle and there's the cup. There are other people that think that this looks more like a plow, so they call it the plow in their country. There's quite a few different names for it, but we call it the Big Dipper over here in North America. The Big Dipper, being part of a larger constellation, is known as an asterism. Aster just means star. So it's just part of a small collection of stars that makes a smaller picture from a bigger picture. Now, what's neat about these stars that are around Polaris, because they're moving around it, and again, notice we're counterclockwise because that's the motion of our axis. The Polaris star is easy to find if you use the constellations around it. The easiest way to find it is to actually use the Big Dipper itself, which is almost always visible in the Northern Hemisphere. And you just go to the last 2 stars on the cup, and they are almost perfectly in line with Polaris, which is a very decently bright star in the north sky. We can also take a look at some of the other constellations. Here's Cassiopeia, the queen on her throne, and another constellation, Cepheus, right beside her. The queen on the throne, if you were to draw a line through these 3 stars here, and then pretty much 90 degrees, not so good in this diagram, but at a 90-degree angle, you would find Polaris pointing, so Cassiopeia sort of points to it at an angle. Polaris itself is the last star in the Little Dipper. Little Dipper, again, there's the little cup, and you've got the little handle there as well. Little Dipper is the asterism that's part of Ursa Minor. So you have the Big Bear and the Little Bear. Now, the Big Dipper and the Little Dipper and Cassiopeia are so close to the North Celestial Pole, and again, remember that the North Star runs right through that pole, that we can actually see them all year round. So in the spring, summer, fall, and winter, you would find the Big Dipper in slightly different positions. Same thing with Cassiopeia. She's always pointing towards the North Star, and she moves around. There's the queen I've drawn for you on her throne. Because these guys are always around that pole, we call them circumpolar. Circum just means around. So around the pole constellations. Please go ahead and complete this activity here. You're going to learn how to read a star chart. You're going to be using the star chart that's on the next page for this activity, and just follow the instructions. It's pretty easy to find where all of these constellations are. Then please complete the lab. The Star Map Lab, read through all this information before you get going on it. But for the first part of the lab, you're actually going to need the separate copy of the star map that I supplied for you. It looks like this. If you don't have your handout, you can always download it off of our online classroom, and you can print it again for yourself. So you're going to be using these dots to help you complete the first part of the assignment. When you've done that first part of the assignment, again, looking for these different shapes and whatnot, then you're going to go through and do the seasonal constellations. You'll also be using these maps here to help you answer these questions. And then what I'd like you to do is go through and pick any 2 of the constellations you learn about, whether it be Ursa Major, Ursa Minor, Cassiopeia, Cepheus, whoever it is, Orion, whichever ones you want to look at. And I want you just to find out 2 of their mythical stories. Not make them up yourself, just go look them up online and see what the stories are. Then for each of the constellations, please write a short paragraph. It's not meant to be a long assignment, that just quickly describes the story. And you can either write that on the back of your star map, this map here, that you're going to be handing in, or you can type it out and you can send it to me separately. And then you're going to upload that to our online classroom. And that, my friends, is the end of this lesson.